We learned forecasting techniques in various settings in the past videos. Forecasting methods are based on data from past observations. To wrap up, I'm going to talk about a specific setting based on an apparel industry. In this setting, we'll use same forecasting tools to build a descriptive distribution based on data from several products. Okay? So in this session, we're going to forecast new products and we're going to look at how to fit distributions. Okay? Basically, forecasting problem for a new product is really a difficult problem because we don't have enough data. There's limited demand data. How do you forecast in such settings? Oftentimes, subjective techniques are used. Let's take a look at some of these subjective techniques. Subjective forecasting methods, right? Some of the subjective forecasting methods we're interested in are through composites. For example, you can look at Salesforce composites. This is sales personnel demand data, and they estimate and they aggregate all the demand data. This aggregation of sales personnel estimates makes your composites. Another method is to collect data or forecast demand is to use customer service. Or you could use a jury of executive opinion, where there is a committee of forecasters and they come up with a forecast and use that collective knowledge. One method that is often used is called Delphi method. What Delphi method does is the following. Individual opinions are compiled and then you reconsider them over and over again until a group consensus has reached. All the subjective methods are eventually based on gut feel and check. Let's look at a forecasting application. We're going to look at a outdoor wear company called Andes. Andes has a product, the new men's hiking suit design. So Andes Incorporation has sold this particular design called Drifter for only one season. Okay. In the past season, they made a forecast of 1,200 units. They made more than 1,200 units. They made 1,500 units, out of which they sold 1,397 units. As you can see from this table, not much demand, and from this not much demand data is available. Now, how can Andes think about descriptive statistic for Drifter, and what would be the mean next year? What could be the standard deviation and things like? That's the question we're going to be looking at. We're going to learn how to fit a distribution by tracking errors, right? If there is a limited past amount of data, like in the case of Andes, for example, for new products, we start with subjective forecast. However, we can do better than that with more data. If you think about it, often there is additional demand data from other products you have forecasted in the past by whatever Delphi method or composites or whatever. That data is informative on how your forecast deviated from the true demand. We'll use this approach on how to fit a normal distribution to such available data. We can use other similar approaches for other distributions. For now, we're going to look at normal distributions. We have data from Andes Incorporation for all their men's shoes. The table shows you all the products that they made in the last season, their forecast in the second column, and then the volume of production in the third column. The sales for those products in the fourth column, and the demand that they saw for all these products in the last column. Right? For example, if you look at the product Omega, right? If you look at this product Omega, the forecast was 2,400. They made 3,000 shoes. They sold 2,967, and the actual demand was also 29 and 67, all of which they sold. Now the subjective forecast for Drifter for the next season is 1,000 pairs. What demand model should Andes use for Drifter? If you look at this table that I showed you, you'll notice that there is a difference between sales and demand. What is sales? Sales is nothing but sensor demand. For example, if your demand was 1,000 units, right, if your demand was 1,000 units, and you had only 800 units on the shelf, the sales is going to be 800 units. You cannot meet all the demand. There are several examples where this happens. For example, popular music players, gaming consoles are often sold out because there is limited inventory. For most operational problems, such as news vendor problem, we need the true demand distribution. We are interested in collecting the true demand distribution. In order to do that, one step we are going to take is to compare your forecast with the actual demand in the table. And here is a graph that shows you the forecast and the actual demand on a chart. On the x-axis is forecast, on y-axis, and on the x-axis is forecast, on y-axis is the actual demand. For example, it's a product, say, for which the actual demand was pretty. Actually, the actual demand is pretty high. For example, here, even here better, the actual demand was pretty close to the forecast. In general, you will notice that some demands are higher than forecast on the upper triangle of the chart, and for some products the demand was lower than the forecast and was in the lower triangle of the chart. Right. So, for example, look at let's look at the demand was here for this product. The demand was about 1,000. The actual demand was about 1,000. The forecast was about 3,500. This chart tells you how typically the true demand deviates from your forecast. If your demand was exactly equal to your forecast, you'll be in the diagonal line in the chart. Using the chart that we saw in the previous slide, in this slide, what we can measure forecast performance now. In order to measure the forecast performance, I'm going to generate another column here and call it AF ratio. The AF ratio column is nothing but the actual demand divided by the forecast. And A stands for actual demand divided by your forecast, F. In this first example, we have 796 divided by 800, that's almost 1. So we measure the forecast versus the actual demand by calculating the ratio of actual demand to the forecast, and this is called AF ratio. We are interested in generating an empirical distribution function of our forecast accuracy. And remember, AF ratio is useful in developing our understanding of forecast accuracy. AF ratio is just the ratio of actual demand to the forecast. We evaluate this actual demand to the forecast ratio of the AF ratio for all, or the AF ratio for all past observation. AF ratio measures how much the actual demand deviated from the forecast. If your AF ratio is 0.8, this means that your actual demand was 80% of the forecast. The AF ratio helps us pin down the uncertainty around the forecast. Right? We're going to learn how to choose a normal distribution and fit it to our data. We start with the initial forecast. Right? We start with the initial forecast. This comes from a subjective method, let's say hunches, guesses, committee forecast, etc. We use the initial forecast. Let's assume the initial forecast is 1,000 units. Then we calculate the AF ratios of the historical data. And recall, an AF ratio is just the ratio of actual demand to the forecast for all the products that we have forecasted. Right? And how do we fit the mu and sigma? Well, that is the mean and the standard deviation of the normal distribution. Right? We set the mean of the normal distribution to the following value. We calculate the expected AF ratio and multiply it by the forecast. And that's your mean of the normal distribution. Okay? So what we do is we calculate the expected AF ratio and multiply it by the forecast, and that's the mean of your normal distribution. For the standard deviation of the normal distribution, we calculate the standard deviation of the AF ratios and multiply it by the forecast. Let's look at an example. In our example, we had a forecast of 1,000. We calculated the AF ratios. The mean AF ratio is 1.01, and the standard deviation And the standard deviation is the AF ratios is 0.31. So when we multiply this by the forecast, we get the mean demand is 1010 because 1.01 times 1000, and the standard deviation of the actual demand is 310, right? 0.31 times 1000. That is 310 to represent our demand. Note, if you want to predict demand for predictive purposes, we need to update the demand distribution. If you want to predict it for later time period or later upcoming products, we can update the normal demand distributions as follows. Mean, we can just keep the same, 1010, and the standard deviation needs to be corrected. The standard deviation will be corrected in the data set from 310 to 390. Why? If you want to learn how to know the reason behind it, go back to the few videos earlier where we corrected our moving in our moving average method. We just calculate the descriptive statistics for our data and in the normal demand model, and we took the standard deviation and we added the standard deviation divided by the square root of the sample size, right? So we updated our standard deviation from 310 to 390, which helps us to measure our our actual demand is going to be how much it's going to deviate from the true demand that 390 is telling us that. And I think this is actually a pretty good distribution model for a very limited amount of data we have, right? We use our forecasting process in the past to come up with some demand distribution that helps us understand how uncertainty in the future looks like, right? And we were able to correct our biases, right? We are able to correct our biases by using the AF ratios, right? And we were able to, even for the predictive purpose, we updated our standard deviation by this formula of sigma equals to standard deviation we calculated plus standard deviation divided by the square root of the sample size. These techniques are very, very broadly applicable, right? These techniques can be used to understand GDP forecast, right? Or in which we compare the forecast with actual observation and can be confident about our forecasting process. For more detail, look at Ned Silver's book on signal and the noise, particularly this chapter 6 called Drowning in 3 Feet of Water. Another example I'll briefly mention is a company called Sports Overmeyer. The forecasting process used in Sports Overmeyer also measures errors. And you can find out more about this in a paper by a very famous paper by Fisher and Rahman. The paper is called Reducing the Cost of Demand Uncertainty Through Accurate Response to Early Sales. So far we have if you are in a business of predicting demand for new product, that's a great paper, and what I presented is kind of a summary or a simpler version of this. If you're in the business of that, I think that's a great paper that you should really look at. But whatever that is, keeping track of forecast errors informs of how good and reliable our forecasts are, and in turn, this information is useful in characterizing the demand uncertainty, how your demand is going to be distributed in the future, and so forth. One of the very famous saying by the chief economist at Goldman Sachs said, figuring out what's correlated and what's causal is a very hard thing. The tool we have covered leverage the past data into coming up with a more predictive model for the future. And we really don't have to know what is correlated and what's causal, but what we have done is, well, we have leveraged on the method that we have in place, right? And figure out, we have natural biases. Maybe your marketing team is more vocal, so you always over predict or overproduce. Maybe your operational folks are more vocal in the team, so you underproduce. Whatever the reason is, you bank on that bias. So what did we do in this chapter? I introduced a news vendor problem. We'll go in more detail of this later. We have set up most of the background knowledge for this. We introduced random variables. We really went back to this random variables idea a little bit more. We introduced demand distributions. We learned how to forecast demand. We learned how to forecast with past historical data. That's a little bit interesting. We looked at the forecast errors and biases in forecast. We looked at two techniques mostly, averages and then moving averages and the trends. We learned how to generate descriptive statistic, more importantly mean and standard deviation. Standard deviation, how to change your standard deviation for predictive purposes. We learned how to adapt them for predictive purposes quite a bit. We looked at trend and seasonality when we learned how to forecast new products and how to fit demand distributions. We'll cover more details in next couple of weeks, and we saw this. We'll make our whole problem around this news vendor model for the most part. We learned how to use Excel for the Excel examples. Basically, the most new thing was the seasonality factor, I did not introduce this in marketing because it's not the overriding factor. In operations, seasonality is a very big factor. So almost every data you have to deseasonalize it and make the models because the data is much more valuable. Data is much more scarce in operational statistics.